Alright, this is my test setup, and I want to just give you a little bit better idea of how these rotors are constructed and how the magnets are attached. My rotors are made out of polycarbonate, 3/4 of an inch thick polycarbonate, and they're about 5 inches in diameter. The rotors themselves, I made them out of plastic just because it's easier to work with and it's relatively inexpensive and readily available, and I can make rotors quickly and easily out of this polycarbonate. Ultimately, I think aluminum or brass is probably a better material, but just for my tests, plastic, this polycarbonate works fine. The way I attach the magnets is I have a brass insert that I drill for and I pound into these holes. You can see I have one here. I got it at Granger, and it's a threaded brass insert, and I just put it in the hole here and I pound it in, and then I use a flathead machine screw, and I put it through the hole in these magnets and just tighten it up, and it seems to hold fine at lower RPM. I wanted to see how much stress these magnets could take, and so I ran the system up to about 3,000 RPM, and before I lost one of these magnets, it flew off. And it doesn't look like the plastic is really good at higher RPM, but I'm finding that the system actually doesn't need to work at high RPM in order to function well. I thought at first, when I started testing the system, that running these rotors up just up to their max, just a few rotors, would produce me the most power, but I'm actually finding that more rotors at low RPM are better than fewer rotors at high RPM. And it's easier on the magnets and the rotors, and I seem to get more power because I've got more interfacing magnets, more spinning magnets when I got a lot of rotors at a lower RPM, and I can get more free energy that way. So that's just a little information I wanted to pass on to you. Alright, so we got a little video here showing you a bit more about the rotors. You can see how the magnets on them are in alignment so that they mesh just perfectly. That's very important. You can have two different size rotors, but if you're going to change the diameter of one rotor and make it different than the other, you're going to have to make sure that the spacing on the magnets stays the same so that they are exactly meshed. This rotor is mounted with a bushing like this, and you can see here how I have a slot in the hole here for the keyway, and it's got 6 holes here on the face. 3 of them are threaded for a bolt, and 3 of them are not, in case you want to just pass a bolt through with a nut on it. So yeah, that gets your rotors get bolted on that, and the whole thing gets pounded onto your shaft of your motor, which is this is the drive motor rotor here, and it will stay on just fine. We have the alternator rod over here, and it's mounted with a nut on the center here, and we'll just take that nut off, and the whole rotor will then come off. So if we just take it off like this, you can see this is the fan blade, which is not connected to the rotors, and then we have the rotor assembly here, and I have 3 T-nuts on the back to hold the bolts in place so that the whole thing is integral, and then just the first rotor section is what takes the nut and holds the whole assembly on, and then I've got a hole drilled in the middle here to get to the nut. So that's basically how that works, and so there you go. Alright, well, this is a little item I wanted to give you a little bit more better glimpse of, and that is my controller here and converter. This is a 3-phase drive motor, and in order to run it on household current, I have to have this converter here to convert the household current to 3-phase. Besides just converting the power, it also lets me adjust the RPM and the startup speed, because if I start up this motor too fast, I'll break the magnetic bond between the 2 rotors, and they'll go out of sync, and the system won't work. So I've got a toggle switch wired up here to turn the system on and off with, but you can see it starts up nice and slow, just like I like it. And then I can adjust the RPM with this. You see these up and down arrows here. You just press the little toggle the little toggle here, a little switch, and you can hear it speed up, and I just hit the down arrow and it slows down. So this is just, I found to be an invaluable little device, and I bought it all on eBay, the motor and the controller here, so they were available as a package, but I highly recommend it.